Hello my dear students, let us continue our discussion on acids, bases and salts. Okay, so in the last class we have started discussion about this acids, bases and salt, right? So in this session we will be discussing what exactly acid and its definitions again, and then next we will be discussing its chemical reactions with metal and also with carbonates and bicarbonates of metal. Okay, so let us start our discussion. So according to Lieberg defined acids as a compound which contains one or more hydrogen atoms, replaceable. These are hydrogen atoms which are replaceable either partially or completely by a metal or a positive radical, okay, to produce a salt. For example, here let us say we have hydrochloric acid, let us say HCl. So upon treating this with sodium metal, okay, so now what happens here? So it will be liberating H2 gas and NaCl is formed. This is what the basic reaction, right? We'll understand, right? So here what we are getting, see, to produce a salt, yes, NaCl is a salt now, so that is what he is saying. Okay, so let us say 2 moles of HCl only I am taking. Okay, I am treating this with zinc metal. Okay, now what we are getting, zinc chloride ZnCl2 plus H2 gas is produced. Similarly, you can take sulfuric acid and zinc. You will be getting zinc sulfate plus H2 gas is released. So in this case, what we are seeing, H2 gas is produced and along with that some salt is formed, right? So he is saying that the acid which contains one or more replaceable hydrogens, when upon treating with some metals, it will forms a salt. That is what he is saying here, and in these examples it will be more clear about that. Now one more thing, what we know generally, acids are substances which have sour in taste. Yes, we discussed yesterday also, and you might be experiencing in your daily life also, like lemon juice you can take, how you feel, and tamarind you can take, how you feel. So these will be sour in taste now because of presence of citric acid in lemon and tartaric acid in tamarind, all these things, right? Next, so what are the general characteristics we have for these acids? Okay, so as we discussed already, most of acid substances have sour in taste. Yes. Now what about action of litmus paper? So litmus paper, acids converts litmus from blue litmus to red. So what they will do? So they will convert blue litmus to red. Okay. Then next, action on methyl orange. So what is this methyl orange? Methyl orange is a weak organic base. What is that? Weak organic base. Okay. And what is its color? So here methyl orange color converts, like orange color converts into red. So it converts into red color. See, let us say in a beaker we have acid, okay, which is colorless. To this I am adding 2 to 3 drops of this methyl orange indicator. Okay, now what happens to this solution? This acid solution now appears to be in the red color. So what is it is indicating? Whenever we are adding 1 or 2 drops of this indicator, initially it is having orange color. When these 2 drops are added into this solution, this acidic solution, now it is converting into red color. This complete solution appears in the red color. So this indicates what? The solution is acidic. Hope it is clear. Okay. So this is what I have mentioned here. Next, corrosive nature. Yes, acids have this corrosive nature. So most of the acids are corrosive in nature. They produce burning sensation on the skin. Okay. So whenever that acid falls on the skin, so it will be having some burning sensation. Okay. So and also when it is falls on the cloths, what happens? We will be seeing holes on that cloths. Okay. This is very powerful, right? So that will damages the cloths also. And see, they also attack on the metal structure and stone work also. Now acids, just now I told you now. So for example, if we have zinc metal, so what happened? So that whenever we are adding acid to that, so what happened? It is reacting with zinc, right? So it is damaging that zinc vessel. If we keep this acid in this zinc vessel or any of these metal vessels, so what happens? It generally damages this vessels, right? So that is the reason we should not keep acids in this like any iron materials or iron vessels or any other metal vessels. Okay, so that will damage the materials. Okay, so now it is always better to keep in the ceramic or glass containers only. Acid always to be stored in the what? In the glass containers or in the ceramic vessels. Okay, I hope it is clear. right? Then next, let us look into some common organic acids and their source. Okay, so what are the source? So these are the general like acids which we are seeing in our daily life. See, vinegar. Okay, so this is a natural source of acid. From, see, we are getting acetic acid from this vinegar. Okay, from orange and lemon we will be having citric acid. Tamarind grapes we will be having tartaric acid. Yes, all these things you need to remember. You should have some idea from which source and from which fruit what is the acid we can get, like that. Okay, from tomato we have oxalic acid. From milk, like curd generally, so we have lactic acid. From ants, when ant bite us, we feel something like sensation, na? So that is because of this methanoic acid. I can also say formic acid. Okay, so from the word formic, see, formica means ant. So from the ants contain acid, that is what the formic acid or methanoic acid. That's why we are calling it as formic acid. Formica, which means it is an ant. Okay, so the source for this acid is ant, right? That's why the name of this acid is given as formic acid. Okay, so what is the structure of formic acid? HCOOH. Okay, this is the structure of formic acid. Okay, then next, olive oil will be having oleic acid. Next, gastric juice in the stomach will be having hydrochloric acid, HCl. Apple, green apples having malic acid. Okay, like that. Urine having uric acid, and the next fresh fruits and vegetables having this ascorbic acid. Okay, and the next bark, wood of tree, tea containing what? Tannic acid, folic acid in the green leaves. These things you should remember, because these are we are using all these things in our daily life, right? So it is better to remember them, the acids and their sources. Okay, now one more thing you need to remember here. See, the basicity or the proteicity of acid are given as, okay, it means, for example, I am giving HCl, hydrochloric acid, right? So now how many replaceable hydrogens it has? So now whenever it is placed in the aqueous medium, the water, what happens? It will releases one H plus ion and Cl minus ion is forming now. So now how many H plus ions are released from this acid? 1, right? So its basicity or its proteicity is what? 1. Like that, if we have HCl, HBr, HF, all these things gives 1 H plus ion. So from 1 hydrogen atom in 1 molecule of an acid. So they are called as, their basicity is considered as 1. Okay, I hope it is clear now. The next, here we have, here also HOCl, HOA, all of them contains 1 H plus ion. Now here you can see HNO3, HClO4, HiO4, HiO3. So this also contain 1 H plus ion. So basicity or proteicity is 1. Okay. Now next, carbonic acid you can see, and phosphorus acid you can see, and sulfuric acid you can see. So sulfuric acid if you consider, so this is the structure of sulfuric acid. Okay, this is the structure of sulfuric acid we can write. Okay, now how many H plus ions it can release? So it can release 2 H plus ions like this. See, it can release this H plus ion and this H plus ion gives 2 H plus, and sulfate ions are formed. So it is giving 2 H plus ion now. So its basicity is 2, like that we should write. Hope it is clear now. So next, orthophosphoric acid. Now it is having 3 H plus ions. So 3 of them will be released. So this is the structure. Okay. So now how many OH hydrogens are there? These are only the acidic hydrogens for this acid. Okay. So it is 3. Okay. For this oxo acids of phosphorus, it is having 4. Okay. So by looking at the structure, we can give how many replaceable or how many H plus ions it can liberate. Okay. In case of H3PO3, if you see here 3 hydrogens are there, but all 3 hydrogens are not acidic. Why? Because by looking at the original structure, so the original structure of orthophosphorus acid will be like this. Okay, like this. Okay, so now this OH group hydrogens are only acidic hydrogen. These are only acidic. This is not the acidic hydrogen. Okay, this is not the acidic hydrogen. These two are only the acidic hydrogen. Therefore, what is its basicity or proteicity? So it is what? How many replaceable hydrogens it has? This one and this one. So 2. That's why I have made H3PO3 in this bracket. Okay, and H3PO4 here. Hope it is clear how we are giving H plus, basicity or proteicity of the particular acids. Okay, about this we will be studying them in the upcoming sessions. So just now get this, whatever the idea I have given, just keep it with you. We will do the questions based on this, because this is very important topic for your JEE and NEET questions also. While solving, it will be very useful. Okay, now next, the chemical properties of acids. So what are the chemical properties? Reactions with metal. Yes, so acids react with metal, and what generally they displace or they release hydrogen gas. Okay, so let us see here. So let us take a metal. Here I have taken zinc metal, and dilute acid, that is sulfuric acid, I have taken as example. Now what it will be forming? Metal salt. See, zinc sulfate is a salt formed, and along with that hydrogen gas is released. Here hydrogen H2 gas is released. Similarly, zinc, magnesium, iron, all these are the example which are generalized example. Okay, now you should also get one question that, so will all the acids will react with all the metals? Will all the metals will react with the acids? No. So there are some things to be remembered here. We will discuss about that. Just follow this. So zinc and magnesium, iron, these are highly reactive metals. Then the hydrogen. Therefore, they will be only displacing hydrogen H2 gas from the respective acids. Okay, let us discuss more about this now. See, do you know which metal which can displace hydrogen from dilute acid is known as? See, the metals which can displace hydrogen gas from their acid, gas from the acid can be considered as active metals. That is what I am saying. Only few metals will displace hydrogen gas from its acid, not all the metals. Okay, let us see. So those metals which are displacing hydrogen gas from acid are called as active metals. So these are the some examples of active metals here I have given. Okay, sodium, zinc, potassium, iron, like this. Okay, next, active metals which lie, see, in the last sessions we have discussed about displacement reactions. Now, so there I have given reactivity series of elements, right? So at the top I have shown you potassium. Let's look here. See, here I have given potassium, which is highly reactive, right? And sodium, which is lesser than the potassium. So potassium is more reactive than sodium. Sodium is more reactive than calcium, like that. So which is least reactive here? Gold. Now the elements which are like before this, which are this side, which are top of this hydrogen, are more reactive. So which are more reactive, and they can displace hydrogen gas from its acid. Okay, so whenever we are keeping this magnesium, aluminum, or this sodium into the acidic medium, so that solution liberates what? Hydrogen gas is liberated from that. So but the metals are the elements which are, like for example, if I treat acids with this copper, generally it won't give hydrogen gas. Why? Because this copper is less reactive than the hydrogen. Okay, that's why it won't liberate hydrogen gas. I hope it is clear. So that is what I have given here. Okay, so now the active metals which lie above the hydrogen in the activity series are electropositive in nature, yes, and their atoms lose electrons to form ions, positive ions, like sodium becoming sodium positive Na plus. Okay, these electrons are accepted by H plus ions of acid, and H2 gas is released like this. Hope it is clear. Manganese, or here magnesium, if you take, here it is 0, here it is in +2. Now 2 electrons are lost by this magnesium. Now that 2 electrons are taken by these 2 H plus ions and becoming H2 gas. Right? I hope this concept is clear. Let us move further. Activity corner. Let us see one activity here. To show that hydrogen gas is produced when the metal reacts with the dilute acid. Yes, let us discuss, let us take one activity based discussion here. So whenever like metals are reacting with dilute acid, we know hydrogen gas is released. Okay, let us visualize that. Okay, so here metals required, for these materials required are zinc granules. Let us say some zinc granules are taken, and the next dilute sulfuric acid is also taken, a test tube, delivery tube, and in that let us say one candle we required and soap solution is required. Okay, so now what to do here? So directly we can go through this experimental setup. See, to this stand we have adjusted this test tube in which HCl is poured. Okay, in this test tube we have HCl gas, HCl liquid. Now solution we have, in that, or sulfuric acid, you can take sulfuric acid we have. So in that we are placing some, we are throwing some zinc granules. Now this black color indicates, let us say, zinc granules. Okay, and now that is adjusted with one cork. To that cork we have kept one delivery tube. So now what happens? So we will be seeing some, slowly some bubbles will coming out. So that bubbles are what? So that bubbles are hydrogen gas. So how do we know those are hydrogen gas? Now the hydrogen gas will enter into this delivery tube and comes out towards this side, and here that tube is adjusted to the soap water. Now what happens? That gas will fills into the soap bubbles. Now see, this is the soap water now. So if soap water, into the soap water, if we pass some gas, what happens? Bubbles will come out now. Yes, so these are the bubbles. Now these bubbles, the soap bubbles, like soap bubble filled with hydrogen gas, right? So now when we place one hydrogen, one candle towards too near to this soap bubble, what happens? That will give some like pop-up sound. See, burning of hydrogen gas with pop-up sound. So it is saying that what? So it is pop-up sound indicates that the burning with pop-up sound indicates what? That is what? Hydrogen gas is liberated during this process. Okay, so this is what the activity we are having in the book. Okay, next. Now how these acids react with metal oxides? Okay, so generally metal oxides are basic in nature. What is the nature of this calcium oxide? It is basic oxide. Okay, so when these basic oxides are there, upon treating with acids, okay, they form respective salt. Okay, salt, this is acid. So basic oxides upon treating with acids form salt plus water. So see here, calcium oxide, CaO is there na, like CaCl2 plus H2O is formed. That is what? Salt plus water we can say. Okay, then next, so I will be also giving you one more example here. Magnesium oxide we have. Okay, so magnesium oxide upon treating with HCl, again let us say HCl only. Okay, here also 2 moles. So what happens? We can expect MgCl2 plus H2O. That's right. Hope it is clear. Now let us take one more example. Na2O, sodium oxide. This is also basic oxide. So upon treating with same HCl, let us say. So what are the products formed here? NaCl. Okay, so let us say 2 moles I have taken this acid. So we will get 2 moles of NaCl plus and H2O is formed. Okay, salt plus water is formed. Hope these reactions are clear now. Okay, salt plus water is formed when basic oxide is treated with acid. Okay, reaction of metal carbonates and metal bicarbonates with acid. So what are the metal carbonates we have generally? So let us say one general example, calcium carbonate we have. So these upon treating with HCl. Okay, so what we can get here? Calcium chloride. So here again this is carbonate, acid gives carbon like salt again CaCl2, okay, plus CO2 gas is released along with this water formation. So these are the things happens here. Okay, what when metal carbonates or bicarbonates are treated with acid, what happens? We will be getting products as one is salt plus CO2 gas plus and water. So these are the 3 things formed when metal carbonates or bicarbonates treated with acid. This is a general formula you can remember. Okay, general statement you should remember. Okay, hope it is clear how we are doing this. Okay, let us write NaHCO3. This is a bicarbonate now. So upon treating with acid, what happens here also? It will forms NaCl salt because sodium here we have. Then next CO2 gas is released and H2O is formed. So this is what happens here, right? Hope it is clear. Everything is balanced now. 2 hydrogens, yes. 3 oxygens, yes. 3 oxygen. 1 carbon, 1 sodium and 1 chlorine, yes. NaCl. Everything is balanced. Like this, we should write salt, carbon dioxide, water is formed. Okay. Hope it is clear. Now, in the next session, we will be discussing what exact definition for bases and what are the different acid-base theories we have, so that once after getting clarity on acid and bases theories as well as exact examples, okay, and exact reactions, what happens between them, so that we can do more reactions and more concepts of this acid bases. Okay, so thank you for watching. So stay tuned with us So let us continue our session in the next session and next class. Thank you for watching.